Hello and welcome to our fractions flipped video. Make sure that you have your recording sheet in front of you and make sure that you are ready to write down this vocabulary. And you do need to copy this vocabulary just as it is written. So let's go over a denominator. The denominator, this is the number on the bottom of the fraction. This number represents how many total pieces there are. Numerator. This is the number on the top of the fraction. This number represents how many pieces you are comparing. So if you look at a fraction and you have 6/10, this is your denominator. I always say dungeon denominator, and this is your numerator, the number on the top. Pause this video right now and you can write down your vocabulary. If you have any questions, you can always contact your teacher if you have any questions about this homework. Let's move on. So, if we're looking at this, fractions always break apart a whole. Okay, so I'm looking at a whole entire circle here. Let's call it a pizza. And if I wanted to share this with my friends, I would have this whole pizza and I have split it into 5 pieces. That's the denominator. The pieces that I get to eat is the numerator, the red pieces, and that is 2. So 2 pieces I get to eat, numerator. 5 total pieces is the denominator. So 2/5 is what I would be able to eat, 2 out of 5 pieces. So let's identify this fraction. Well, how many total pieces are there? There are 1, 2, 3, 4. There are 4 pieces. That is my denominator. The number that's shaded in yellow is 1, 2, 3 pieces. So 3 out of 4 pieces are shaded in yellow. And you can also do the opposite. How many are not shaded in yellow? Well, that would be 1/4. And if I put these two together, that equals this one whole right here. The whole circle. So let's look at this fraction. It looks a little bit different because it's not a circle. So let's call it brownies. I know that there's 2 pieces here, 3, 4, 5, 6, 7, 8. My denominator is going to be 8 because there's 8 total pieces out of this whole brownie. Or you could call it a whole tray of brownies. How many are shaded in? 1, 2, 3, 4, 5, 6. So 6 out of 8 pieces are shaded in. So that means that I would be able to get this much of the brownie tray. I'd be able to eat that much, which is really great because I love brownies. And if you wanted to know how many pieces I don't get, well, I don't get 2 out of 8 because these 2 are not shaded in. Let's talk about equivalent fractions. That means equivalent sounds like equal. So it's asking, are these 2 fractions equal? Well, let's look at how much is shaded in. I'm looking right here. 2 out of 6 or 1 out of 3. 2 out of 6, 1 out of 3. If I'm looking at these shaded pieces, then I am going to know that they are the same. Yes, they are equivalent because the same amount is shaded in both. So I know that 2/6 is equivalent to 1/3. Let's look at 3/7 and 1/8. Well, if I'm looking at the picture, clearly 3 out of 7 pieces means I get to eat more than 1 out of 8 pieces. Remember that when you're dealing with fractions, the larger the denominator means the smaller the pieces you're getting. That's the key. The larger the denominator does not mean that your fraction is larger. The larger denominator means that the pieces that you are getting are smaller. So I would much rather have 3 out of 7 pieces than 1 out of 8. I'd even much rather have 3 out of 7 than 3 out of 8 because I am getting larger pieces. So these are not equivalent because the same amount is not shaded in for both rectangles. Let's talk about improper and mixed fractions. So an improper fraction means that the numerator is larger than the denominator. So if I had something like this, that is not a proper fraction. That is an improper fraction because 10/5, how is that even possible? My numerator is larger than my denominator. A mixed fraction would mean that they include a whole number and a fraction. So let's go and say I had 2 and 1/5. That means that I have a whole number and then a part of a whole. Okay? If you have an improper fraction with a numerator larger than a denominator, that means that there's a whole number in there somewhere. So, here are the improper and mixed fractions. It's not how many I have shaded in is my denominator. My denominator is how many one of these is split into. My denominator is not going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. My denominator is not going to be 10. My denominator is not going to be 12. My denominator is how many only one of these is split into. They are all split into 4 pieces. So my denominator is how many pieces one circle is split into, which is 4. Then my numerator is how many are shaded in, 10 pieces. If I go over here to the mixed fraction, I have 2 wholes right here and 2 fourths. So 2 wholes and 2 fourths. That's how much I have shaded in. So both of these are equivalent. One of them is improper and one of them is mixed. Whoops. Let's identify this one as a mixed fraction. I know I have one whole circle filled in, and how many pieces is only one of these split into? My denominator is not going to be both of these combined. I only care about one of them. So there's 1, 2, 3, 4, 5, 6. That's my denominator, is how many pieces one circle is split into. And then how many are shaded in? 1, 2, 3, 4. 4 out of 6 are shaded in. So 1 whole and 4 sixths. My denominator is still going to be 6 because only one of these circles is split into 6 pieces. How many total are shaded in? Well, there's 4 over here plus 6. That makes 10 sixths. That's my mixed fraction. This are my improper fraction, and this is my mixed fraction. Let's do another one. How many pieces is just this circle split into? It's split into 1, 2, 3, 4, 5, 6, 7. That's going to be my denominator for both fractions. Let's do the improper fraction. So there's 7, 8, 9, 10 pieces shaded in. If I'm looking over here at how many are shaded in for my mixed fraction with a whole number, this is 1 whole shaded in, and this is 1, 2, 3 sevenths shaded in. My denominator stays the same because I only care about how much one of these circles is split into. Next, let's make our mixed fraction. Let's mix it up. So I have 1, 2, 3 wholes and 1, 2, 3 out of how many? Fifths. So I have 3 wholes and 1, 2, 3 fifths shaded in. Now if I want to count these, this is 5, 10, 15, 16, 17, 18. 18 fifths is going to be my improper fraction because my numerator is larger than my denominator. This one got a little bit tricky. If I just look at this, only 1 whole is shaded in. But that's not true. If I move this piece over here, I can make another hole shaded in, and then I would mark it off over here. So this is split into 1, 2, 3, 4, 5 pieces. I have 2 holes and 1/5 because I moved this piece over here to make this a hole also. Now if I do it as my improper fraction, I know that I have 5, 10, 11 fifths shaded in. Because I scooted this one over here. I just scooted it over to make this complete. Okay, this one's tricky again because this one's not complete. If I move this piece right here and shade this in, now it's complete and I don't even need this box anymore or rectangle. So now I have 2 holes and 1, 2, 3, 4. 4 is going to be my denominator. So I have 2 holes and 2 fourths shaded in. If I count, I have 8, 4, 8, 9, 10. I have 10/4 shaded in. I know I went pretty fast in this video, but please feel free to pause this and rewatch it as many times as you need to so that you can understand the concept of fractions and improper and mixed fractions, because we will be talking about it next week. So I hope this helps you. If you have any questions, please feel free to ask any of your teachers. Happy flipping!